Have you ever looked at a landscape and wondered what ancient forces shaped its hills and valleys? Imagine colossal sheets of ice, miles thick, slowly carving and depositing materials as they retreated. What kind of unique geological signatures would they leave behind? When glaciers melt, they leave behind distinctive landforms. Among the most fascinating are eskers and kames, which differ primarily in their formation process and the way meltwater deposits sediment. An esker is a long, winding ridge of stratified sand and gravel formed by a subglacial stream. A kame, in contrast, is an irregularly shaped hill or mound composed of sand, gravel, and till, often formed by meltwater accumulating sediment in a depression on or within the glacier. Let's dive deeper into eskers. Picture a river flowing not on the surface, but underneath a massive glacier, often within an ice tunnel. This subglacial stream under immense pressure carries a significant load of sediment. As the glacier melts and the water loses energy, this sediment, which includes sand and gravel, is deposited along the stream bed. When the surrounding ice finally melts away, the riverbed material is left standing as a raised, sinuous ridge. Because it was deposited by flowing water, the sediments in an esker are typically well sorted and stratified, meaning they are laid down in distinct layers. They often appear as long, narrow embankments, sometimes extending for many miles across the landscape. Now let's consider kames. Kames form in a different environment, usually where meltwater collects in holes, crevasses, or depressions on the surface of or within a stagnant or slowly melting glacier. Imagine a pool of water forming on top of the ice, or a crack filling with sediment-laden water. As the ice around these features eventually melts, the accumulated sediment collapses and is deposited directly onto the land surface below. This process often results in irregularly shaped mounds or small hills with chaotic, poorly sorted, and unstratified deposits, reflecting the more haphazard way the material settled as the ice support disappeared. Kames are typically smaller and more isolated than eskers and often occur in clusters. So how can you spot these in the field? To identify an esker, look for a winding, snake-like ridge, often cutting across other glacial features. Its smooth, rounded top and sides hint at water deposition. Kames, on the other hand, will appear as more isolated, hummocky hills, sometimes with a steeper, more irregular profile. If you were to examine a cross-section, an esker would show distinct layers of sand and gravel, while a kame would reveal a jumbled mix of sediments, from large boulders to fine clays. These landforms are not just geological curiosities, they are significant resources. Eskers, in particular, are highly valued sources of sand and gravel for construction, often referred to as aggregate. Because their sediments are naturally sorted and relatively clean by the action of flowing water, they are a prime target for quarrying. Understanding their formation also provides valuable clues about the movement and behavior of ancient glaciers, including the direction of subglacial water flow and the extent of glacial ice sheets. They are crucial indicators for paleoglaciology, helping scientists reconstruct past ice ages. Ultimately, the distinction between an esker and a kame tells a detailed story about the precise conditions under which glacial meltwater deposited its load. Eskers reveal powerful, channeled subglacial streams, while kames point to more localized, stagnant meltwater accumulations on or within the ice. By understanding these subtle yet significant differences, we gain a deeper appreciation for the immense power of glaciers and their lasting impact on Earth's surface, offering insights into environmental processes that shaped our world.